We calculate this 27.56 into HA. HA value is 72.8 minus 61. That is value is 325.21 kilojoule per minute. Okay. Similarly, we calculate the latent heat load due to infiltration. Latent heat load due to infiltration. Latent heat load due to infiltration of air. This is L1, latent heat load. So mass flow rate into enthalpy drop between latent heat portion. That means 1 to A. That means H1 minus HA. Okay. Similarly, we get from this diagram in psychometric chart we get H1 HA and we calculate M dot A. So we get this is 336.23 kilojoule per minute. We convert it into kilowatt, both of them, QS1 and QL1, 5.6 kilowatt. Okay. Now in the question, two parameter is also given: sensible heat load and latent heat load. Sensible heat load is given 46.5 kilowatt and latent heat is 17.5 kilowatt. Okay, due to infiltration we get sensible heat, how much amount? 325.21 kilojoule per minute. We have to convert this into kilowatt, that is divided by 60. That means 5.42 kilowatt. Our latent heat due to infiltration is 5.6 kilowatt. Total sensible heat and total latent heat is how much? 51.92 kilowatt and here 23.1 kilowatt. Okay, total. These two load is transferred to the room, or another two load is also transferred to the room due to infiltration. This portion due to infiltration, this portion is due to infiltration. So that AC load is also increased because AC load is before infiltration of air. AC load is 46.5 and 17.5, but due to infiltration the load is also changed. This and this amount is added to the system, so the total load of the AC is increases. Okay, now this amount is room sensible load, this is room latent load, because both sensible load is transferred to the room and both latent load is transferred to the room. So that room sensible heat factor is room sensible heat by room sensible heat plus room latent heat or total heat. Okay. How much amount? Just putting this value, we get 0.692. Okay, 0.692. Now here protractor is available in the psychometric diagram. So please mark this point. 0.692 means that suppose this point is here. Suppose 0.692 or 0.7. Draw the this is the room sensible heat factor line. So room sensible heat factor line must be passes through the room point. Okay, the room point is 2 and room sensible heat factor line is this. So draw the parallel line which is passes through the parallel to the room sensible heat factor line and passes through the point 2. Okay, suppose this is our point. Okay, this is our point. This green line parallel to the this line. Okay, now what is this point? This point is 3. This point is 3. Okay, this point is 3 and the room sensible heat factor line passes through point 2. Room sensible heat factor line is passes through the point 2 and 3 and room ADP. Room ADP means this point. This point is ADP of room. If bypass factor is 0, then room ADP and coil ADP is same point. Okay, here now we have to calculate the point 4. That means supply point. How we calculate this? Nothing. 3 point, we get 3 point intersecting point, this point and this line and this line, 0.3. 0.3 temperature is how much? 0.3 temperature is 19 degree. Okay, so first of all, the used air, 60% of used air is mixes with the 0.3. That means this is 40%. That means 60% means 0.6 into used air is 27 degree plus 40% of 3. That means 3 point is 19 degree. We 19 degree we get from our psychometric chart. How much this? Almost 24 degree, almost 24 degree or 23 point something. Okay, this is our 4 point. Okay, now in our numerical, determine the condition of air after the coil. That means 3 point. Condition of the coil. 3 point. 3 point is the condition of the coil. First of all, 3 point is 19 degree. T3 is 19 degree. we have to determine the condition point of the 3. What we get at 3 point T3, TW3, that means weight bulb at that 3 point weight bulb is almost 18 degree or 17 degree. Okay, what we get from 3 point, if we draw parallel line here which is cut it in that line, we get W3. Similarly we get phi 3. Oh, all the points. Okay, number 1 calculation is over. Okay, now in our numerical, point 2, condition of air entering to the room, condition of air entering to the room, condition of air entering to the room, that is point 4. Point 4 is the supply point. Point 4, how we get point 4? T4 is how much? 0.6 of used air means 27 degree plus 0.4 of 19 degree. What do you get? Almost 24 degree or 23 point something. Okay. Okay. First point is over. Similarly, we get TW4. The first of all mark T4 is 24 or 23 degree.